And welcome back to the Digital Cash Evolution here on 1100 KFNX. Definitely give us a call here, and the producer will take your name and number, and you can get free money. I mean, who doesn't want free money? This is actual real money, not that paper stuff that they keep printing over and over and over. QE infinity. Oh my God, what is that? That's one thing that cryptocurrency solves. It's not printed endlessly. There's a finite amount. It's like gold. It's digital gold. That's exactly what it is. And there's also something else that we're going to be giving away. And it'll be actually in a couple of months. So what we're going to do is people that are getting these wallets and getting this free Dash and Bitcoin, we're going to put you into a drawing. And in about 8 or 10 weeks, we're going to give away a Ghost Gunner. I don't know if you know what that is, but it's a CNC milling machine that allows you to, well, make your own gun if you want. And this is perfectly legal. I think California is putting a kibosh on it on July 1st, but it is still legal everywhere else, other than, I think, North Korea and a few of these other places. So, yeah, this is going to be interesting. Go to ghostgunner.net and check out that machine. And if you're a Second Amendment supporter, like the creator of ghostgunner.net, which is Cody Wilson, then you might be interested in this.
Yeah, we got Theo Chinos chiming in here on our live stream here saying, this is an intangible commodity. Our good buddy Morpheus, who was prosecuted for doing illegal activity of trading Bitcoins.
But that's not
Theo
illegal.
Theo has supported Morpheus with that case, and Morpheus coined that term, and Theo's reminding me to say call this intangible commodity, which I think is a really good word for the type of what Bitcoin and what the cryptocurrencies are.
Another name that gets thrown around quite a bit is Ethereum. If anybody knows, any little bit at all about Bitcoin, they've probably heard about Ethereum. And Ethereum is trying to solve these smart contract problems. And since we have, Colin here, he's got a new white paper out that's connected to Nexus that wants to solve those problems even better. Colin, give us the rundown on what Ethereum is, what they're trying to solve, and what Tritium does.
So what Ethereum's been trying to solve is basically having, you could call it a distributed computer, where you can program on a specific language and then the state of any execution of that is recorded on the chain so that you have trusted execution models, I guess you could call it. And so they developed what's called the Ethereum virtual machine as the interpreter, and then Solidity and other languages as kind of the language layer, where you can program in a specific language and it's Turing complete, and it allows you to create tokens, or it allows you to do supply chains.
Can you give like a brief, simple description of what Solidity is?
Well, so Solidity is a language that is compiled into bytecode, or Ethereum virtual machine instructions. So a virtual machine is virtualizing what a computer already does. So when you make, let's say, a compiled binary, you have what does go into straight native operating system, or not operating system, processor level bytecode, which basically tells the processor, I need you to add these numbers, I need you to store in this register, anything else. The Ethereum virtual machine emulates that by having their own set of bytecodes. So Solidity is a language, a programming language that you would program in, and then you compile it, and it turns into native interpretive language for the Ethereum virtual machine that allows that to execute on the blockchain, and every node will execute that code and agree upon a certain state of all the variables within that after that execution, which allows you to basically program on a blockchain in a way that it can't be manipulated or changed.
So Ethereum actually started with Bitcoin on colored coins. And this was the idea where you could put assets, just tag an asset to a coin, and whatever coin held that asset, then that was your, proof that you own the asset or whatever. How did Ethereum kind of differ from that? And how did it move away from that, and what did it solve? Because I know, I guess Vitalik wanted to solve other problems that the guys that were developing colored coins weren't really interested in doing.
I'm not sure of that past. I heard ties to Mastercoin or something like that as secondary protocols. But what I do know is from looking at their code that Bitcoin has a scripting engine in it. So it's designed to be programmable money. And it was deliberately designed not to be Turing complete. So it was limited in what you could do. You could, use a certain set of opcodes, but then you had to program in that actual native language. It was not something that you could actually compile into. So Ethereum made it Turing complete, which means that it could do everything that a Turing computer could do. But the biggest power, at least what I isolated from it, is their ability to have contracts talk to one another and send data to one another. So what that happened is that allowed self-executing programs to exist as transactions, which then could be programmed in a higher level language like Solidity, which gave rise to the ability to create ERC20 tokens or any of their other token standards or CryptoKitties or other things like that, to use it as, I guess you could call it a data storage truth box in a certain level, and a processing truth box.
To give a kind of a simple description of what Ethereum was really meant to do, can you describe Slockit, like how that was supposed to work with Airbnb?
Oh, the DAO?
Yeah.
You're talking about?
Well, that failed, but I mean, it was a good idea.
Yeah. Yeah, it was.
I mean, kind of just give a description of what that was supposed to do for Airbnb. I guess your smart contract would activate the lock on a door.
I'm not necessarily sure about what Slock did. I know about the DAO, but I mean, having an authorization system where it could unlock the door, you could have something tied to a cryptographic identity and make a signature, and then have that, let's say, lock communicate with the ledger to be able to prove that event happened. And you could do something similar to that. I'm not exactly sure about their architecture.
Right. I mean, lease cars, all types of different things
could be
operated by these smart contracts, so that if you weren't paying on your car, well, your car would just shut off on you, and they wouldn't need the software or whatever that the car lot's doing. It's just automatically, built into the initial purchase of the car. Let's get into what you're trying to do. What is it that Tritium is trying to solve?
So we're trying to solve the scalability of it and also the modularity of contracting engines. So right now, I usually use the analogy of, think about a piece of gum. If you try to pull a piece off of it, you got all these strings attached, and it's really difficult to interchange pieces. Tritium is basically modular on many different levels, and we break up the stack just like the internet is broken up in a stack. It's not one big glom of code. It's different layers that interact with one another, and these layers of abstraction allow different developers of different types to make better decisions. So let's look at Slock.it and the DAO. The code is reviewed, they thought they were right, and then it ended up having a security vulnerability because it was just a simple deployed program. They raised a lot of money and there was a lot at stake, and so somebody went and attacked it. And they may or may not have been qualified to write that. I can't speak for them, but based on the events that happened, it seems like they weren't. So when you have an overcomplexity and a lot of security based upon the system, and you have it all abstracted as one layer, you create a lot more prone to error, and you also create a completely generic system that has a higher barrier of entry for people to be able to understand how to utilize. So by breaking Nexus up in the Tritium software stack into layers of abstraction, any different type of developer can get on different levels. Like we have Dino helping on the actual network level, which is on the IP layer with Lisp. And then, I'm working with some of my team on the ledger and the register level. And then we're going to be working with businesses and other very low level programmers defining the operation codes for the operation layer. And then businesses, of course, are going to help define the API layer and what calls they specifically want on top of that, so that when you're building a decentralized application, you're going to be able to interact directly with the API layer, and then all this stuff underneath is going to be doing what it's meant to do without an overcomplexity, so that it scales, and then also with a high amount of testing and working groups based in it. So that's how the internet becomes what it is. It takes time for different protocols to be rolled out, and they have to be tested, and they have to be attacked in many different ways. And there's almost a vetting process for different documents where you get RFCs or ISOs. So in a similar type of way, we're doing that. Since blockchain is similar to the internet, we need to have a decentralized way to have the protocol standardized and move forward.
So you will, let's break that down into English. You're going to have more checks and balances than Ethereum.
Well, yeah, and it's going to be, how should I say, it's going to be easier to integrate too, because like I said, there's this, at least my observation anyway, is that developers sit at this top and they say, we've built this and this is the future, and now you have to figure out how to use it. And then they may change things out from under businesses that are trying to build on it. And it makes the integration process very difficult. So we want to integrate those together. We want to have people be a part of it and be able to help tell us what they need.
How can people find out more about Nexus?
You can go to nexusearth.com or follow us on Twitter. Check us out on Facebook, NXS Earth.
definitely check out Nexus and check us out at thecryptoshow.com. Hit us up on Facebook, the phoenixcrypto.com.
phoenixcrypto.com. And something fun on the side here. Phoenix Crypto just got a mascot, little baby boa constrictor. So we're doing a fun little giveaway. We're going to give away a Trezor, which is a Bitcoin hardware wallet and multi-crypto hardware wallet. Go to hashtag name the snake and give us your name suggestion. She is a female, so we're doing hashtag name the snake. The winner's going to win a Trezor hardware
And
wallet.
come out tonight at 6 at the Monastery Bar and
4810
Grill.
East McKellips Road.